everyone, I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, the discussion for the topic we selected line integrals. What we are going to discuss in this video lecture, definition of line integrals, problems based on line integrals. First, this line integral, it is an integral of functions defined along the curve. That is, a curve it is there. A function which is defined. For that, the line integral is used. The line integral which is used to calculate the area of the surface in 3 dimensions. This is the very important of using this line integral. Now, here we can notice a curve. That is, the point of the curve which is denoted A. The end point is denoted by B. That is the curve, the direction which is given here. That is the arrow mark which represents that. The curve name is C we have taken. And there is a point on the curve. At that point, we can draw a tangent. That is the line segment which touches the curve at one point. We know it, that is tangent. Now, capital F bar of t, it's nothing but vector r. It is a smooth curve. That is, here this curve is a smooth curve. The meaning is the curve is continuous and differentiable. Continuous, the condition is limit x tends to a, f of x equal to f of a. It is there we can tell it is continuous at this particular point a. Now we have taken our point is P. It is on the line on the curve. Now, differentiable. That is limit x tends to a plus f of x minus f of a divided by x minus a. That is, here x is greater than a. We will substitute, we will get the result. That result should be equal to limit x tends to a minus, that is x is less than a. These both conditions are satisfied, then we will call it as it is differentiable at this particular point a. So our curve is, whatever the points lying on the curve, they are differentiable and continuous. This is very important for the line integral. Now, so this is A and B are the starting and end points. ds is the differentiable of arc length. That is, S is the length of the arc. ds, it is a differentiable. This vector t is defined as, that is the vector t is the unit vector. The differentiation of r with respect to s, it's nothing but the vector t. It is a unit vector, that is the magnitude is 1 along the tangent. Here the tangent at this point touching at the curve at the point P. That's what to the curve C at P. Now let f bar of r is a vector point function. That is, to the point P, we will associate some real numbers to the vector function that is called vector point function, defined and continuous along C. Because we know it, ours is a smooth curve. So it is continuous and differentiable. Now we want the components of this vector. To get the components of vector f along the tangent at P is vector f dot product vector t. So the integral vector f dot vector t ds, it is integrated with respect to es, taken along the curve C is called the line integral of vector f along the curve C. This is also written as our curve starting to ending the points A and B. So f dot t ds, the bar it denotes it is a vector. That means not only magnitude, it has direction also. Then it is vector. If it is only magnitude, then it is scalar. Now, ours is a curve. It's our curve name is C. This vector f, the vector t is a defined, that is the differentiation of our vector with respect to s into ds. It's nothing but integral over C, the curve C, f dot dr. This is the dot product. The dot product I dot I equal to the value is 1, j dot j the value is 1, k dot k the value is 1. This we have to keep in our mind while solving the problems. Now work done by a force. If this vector f represents the force vector acting on a particle moving along an arc AB, then the work done during the small displacement, that is del r. So the displacement, the particle moving from starting to end point in the specified direction. If it is only distance, the length we will calculate. But displacement, which particular direction the particle moves from starting to end point is del r. Then how much work is done? That is nothing but vector f dot del r. Hence, the total work done by vector f during the displacement from A to B is given by the line integral A to B f dot dr. So we will concentrate a problem, that is, if here it is given vector f equal to x square plus y square I minus 2xyj ij k, but in the question only it is given I and j. Evaluate the integral over C, that is along the curve C. Ours is a closed curve. Closed curve in the sense, the particular our problem is a closed curve where the starting, the particle, it will comes to the starting point itself. So now here is the curve. It starts the point A, it moves and it is coming to the starting point. That is, starting and end points are coincides. It is a closed curve. F dot dr we have to calculate. Now, where C is the rectangle, that is the particle moves in rectangle way, that is like this it moves. In the xy plane, it is given strictly it is two dimension. That is the reason here also the k, the mutually perpendicular vector, it is not given. Only it is given I and j. So this rectangle, the curve formed by, this is the boundaries. With these boundaries, first we have to draw in the two-dimension xy plane the rectangle closed curve. That means the particle moves from the way it moves in a rectangular way. The solution is, since the integration take place in the xy plane, so the question which is given xy plane that we are reproducing, since the integration take place in xy plane, if it is three dimension x, y, z, our problem is two dimension. That is the reason z equal to 0, it is mentioned here. The next, in the question it is given the closed curve f dot dr to be evaluated. So it is written here. We know it, this vector f, it has the components f1, f2, f3. I, j, k are the mutually perpendicular vectors. So this f vector to be compared with our given question, given problem, our f1 is playing what is the role, f2 is playing what is the role, and f3 it is not there since it is xy plane. So we are doing the comparison. F1 we got it, this is x square plus y square. F2 it's nothing but minus 2xy. R vector is xi plus yj plus zk. The differentiation of R vector is dxi dyj dzk. The plus signs are retained as it is. Here we are not taking dz, we are neglecting as it is xy plane. There is no, in this particular problem, there is no third dimension. It's strictly now dr, the differentiation of r vector equal to dxi plus dyj. The line integral formula is integral over c f dot dr, where f is playing the role f1i f2j plus f3k. This is our question, that is f x square plus y square of I minus 2xy j, we are substituting the f place we wrote it. What is this is substituted there. The dot product as it is written. The dr, just now we discussed it, that is written here. So now we are going to do the dot product. In the dot product, I dot I, the value is 1, j dot j equal to 1, I dot j all equal to zeros. So now this is I dot I. So multiplying, we are getting f1 dx, j dot j, we are getting f2 dy. So it is written here. In this step also, this we neglected because it is related to z plane. So z plane only, it is not there. So this is not written here. So we did the dot product. So f1 dx plus f2 dy. After doing this dot product, we are getting our f1, it's nothing but this is our f1 in our given problem. f2, this is minus 2xy. So we are substituting in our closed curve C. We are naming it as equation 1. Now, this is the bounded, the boundary. The region is bounded by these, the limit points. So first, looking at this limit points, we will draw the diagram. Since in the question it is given xy plane, so we have drawn x-axis and y-axis. So we named it as x, the horizontal line. The vertical line is named as y. The origin we have taken as O. The coordinates are 0, 0. Now here, y equal to 0, y equal to b, x equal to 0 and x equal to a. With this help, we have to draw a rectangle, because that is also mentioned in the question. The particle moves in a rectangular way. After moving, if you are joining the points, the shape is rectangular. That is a closed curve. That means our particle is going to start from the origin. It is a closed curve, so taking a movement, it should come to the starting O itself, starting the origin itself. It should coincide with our origin. Now, the particle starts from here, the x-axis. It moves along the x direction. That is, it moves horizontally. When it moves horizontally, so it starts from 0 to some point. That means it should cut at x-axis at some point. It is given x equal to a. So to draw this, with these limits, we are going to draw the diagram. So now, here the point it is there, that is x equal to a. When x equal to a, y equal to 0, so it moves x direction, so the y is 0. Because the point A which lies on x, the meaning is y is 0. Now, at the point x-axis, it cuts at A. that we named it as P. So now our particle is here. From here, it is taking the direction. And this direction also, that means the arrow mark, which is animated here. It shows that from the particle, it starts from origin and it cuts x-axis at the point A. We named it as P. Now the particle is here. From here, it is going to move. It is not going to come back because it is a closed curve. Closed curve, a point it starts, it will move, it will coincide with the starting point. So we are here. Next, we have to see the point. So it is taking the direction and it is moving. So at one point, so it moves vertically. That means parallel to y-axis. In the y direction it moves. At what point? So we know it here, x is a and it is given y equal to, so we can see it b. So a, here b. The point name is q. Before that, we can see it here, y equal to b it is given. So the first here wanted y equal to b. That means it cuts the y-axis at the point b. So y equal to b, the line. To say this line and this line, the intersecting point is q, that is named it as, that is a comma b, the naming is q. So now we are in q. So we moved here touching the y-axis at the point b. So the y is b, x is nothing but 0. This point we named it as R. So now we can see how we are looking over these animations. The origin, y equal to 0. The particle touching the x-axis at the point P at the coordinate a comma 0 and y equal to b. So it cuts y-axis at the point B. This is the direction for OP it is taken. And from P it moves upward. And the point is nothing but A comma B. So this intersecting point is named it as Q. And from Q the particle moves and touches the y-axis at the point B. From this, we are naming it as R. From R to O, the direction is given. So 1, 2, 3, 4. Forward direction. Moves, moves, movement, movement. It is not coming back. Forward steps. Because it is a closed curve. This point should be very, very clear. Now, we know it, our line integral formula is f dot dr. But our closed curve is in rectangular shape. So, from particle from origin, our origin we named it as O, from OP it moves From P to Q it moves, from Q to R it moves, from R to, again it coincides with our starting point, our origin, O. So these four integrals we have to find now. This is the condition of that limits. Using that, we have drawn this diagram. Just now we discussed it. Now, this integral first. We are going to evaluate this first integral now. So, integral, the first, from here OP integral. That's what it is written. It moves in the x direction. If it moves in the x direction, the meaning is there is a movement from O to P. OP. That means x varies from 0 to the point A. That's what it is written. X varies from 0 to A. Now, this integration we have to do as it moves in the direction of x. We have to do the integration with respect to x. We have to do it. Dx to be found. Fine. Here, in this, we are in OP. The first integral we are evaluating. In this, what is x? Here we can see it here. Sorry. This is x. This we completed. Y part here. Y is 0. Y is 0, then dy equal to 0. This is initially we discussed, that is f dot dr we found. In this, these we are going to substitute. So y equal to 0 and dy equal to 0. So this complete part it is becoming 0 and this part also it is becoming 0 if we substitute these two. So integral, the first OP we are calculating, that's what it is written, OP, f dot dr. Already we found f dot dr, that we named it is also, we named it as equation 1. We substituted these values. Finally we got it, x square dx. The integral varies from 0 to a. So the x square integral, it's nothing but x power n dx. It's equal to x power n plus 1 by n plus 1. So the x square integral is x cube by 3, 0 to a. Now 1 by 3, x cube 0 to a. So the upper limit is a, the lower limit is 0. We substituted in the particular place the upper limit, it has become a cube. The lower limit is 0, we neglected it. So the first integral we calculated, we got it a cube by 3. So our particle is here. We calculated this is, the value is a cube by 3. Now we are going to calculate from P to Q. This is completed. Now we are going to focus this one. So from P to Q we are moving, the direction also given. We are moving vertically, that is y direction we are moving. If you are moving y direction, then y varies from 0 to b, 0 to b. We have to do the integration with respect to dy. That's what it is written here, dy. What about x? We can see it. Our x is a. That's what it is written. If x equal to a, we know it, the differentiation of constant is 0. These values to be substituted in our equation 1. According to that, our this term is totally cancelled because dx equal to 0. Here we are substituting minus 2xy. Here x is taking the value a. So now it has become minus 2ay. We have taken this integration. We are integrating here with respect to y because the particle moves in the y direction. Just the 2 minus 2a we have kept before the integral from 0 to b y dy. This 0 to b, it's nothing but this 0 to b, the y direction. Next, y integral is minus 2a, it is written. Y is y square by 2, the integration using the formula, simple formula, that is integral of x power n dx equal to x power n plus 1 by n plus 1. So our y power is 1. So y square by 2, limits from 0 to a. This 2 getting cancelled, minus a, it is written as it is, y square 0 to b. So minus a. So y place we are substituting. So upper limit b, we substituted in the place of y, it has become b square. This is limit formula, upper minus lower. So y place we are substituting 0, it has become 0. Finally we got it minus a b square. So the second, our particle from p to q, it is moved, it is calculated, the value is nothing but minus a p square. So the 2 we completed. Now we are going to focus from our particle from q to it moves to r. So qr we are going to focus now. So this is f dot dr that already we calculated. Now we are moving in the x direction. That's what here x varies from. Here we have to be very careful from where it moves. So from q to it moves to r. So from a to 0. It's not 0 to a because as it is a closed curve, the direction it won't be changed. If it forward it moves, it will come to the starting point. Now as it moves in the x direction, so we are going to do the integration with respect to dx. Before that, here what is the role y is playing? Y equal to b. So the differentiation of y, here b is constant, which is 0. So this is the line integral formula. It should be written here, qr. This we are calculating. So a to 0. So now here we are substituting dy equal to 0. This complete, it has become 0. Y is going to take the value b, so it is becoming b square. That's what here it is written, x square plus b square, and integration with respect to x because here it is qr. it moves horizontally. So with respect to x. So x square, the integral is x cubed by 3. B square is written as it is treated as constant. Dx integral is x. Now, the upper limit, in the place of x we are going to substitute, so it has become 0, formula minus. In the place of x we are going to substitute x plus a, so it is a cubed by 3 plus, here this x is taking the value a, so it has become ab square. So here minus a cubed by 3, and here minus we are taking inside, then it is minus a b square. So now we evaluated the third integral also. Now we have to focus the last one. So we are here now, from here to the origin, that is named it as O. We are going to move and we will come to an end of this cycle, the closed curve. Our curve is in rectangular path, it moves. So f dot dr, it is already done. Now RO, so it moves y direction. Then y varies from b to 0. That's what it is written. Here x is playing the role x equal to 0. Then dx equal to 0. Here it is written actually. It is a typing thing. RO should be there. So integral b to 0. 0 into dy. It has become totally, this integral is vanished. Now, so we have done it. 4 integrals we calculated. So here this is the one correct one, OP. Here it should be kept here PQ. Here it should be kept QR. It should be R. So now, hence from equation 1 and 2, here we can say it, this is the equation 1. This complete thing, equation 2. So this is the diagram. Looking at the boundary conditions, we have drawn this one. Just we substituted the first integral evaluation. This is the second integral evaluation, third one, and the fourth one. So simplifying, we are getting this, both are getting cancelled. Minus 2a b square we evaluated for this rectangular path closed curve. So we will come to a conclusion of this topic, line integrals. The definition of line integral, that is, it's nothing but integral over C f dot dr. So the line integral formula, so it is a closed curve f dot dr, and the line integral which is used to find the area of the some functions, to find the or integrate some functions along the curve which are defined. We have taken your problem f equal to x square plus y square I minus 2xyj, and we are asked to do evaluate f dot dr and these conditions to form the bounded region. These conditions are given. Along that we have drawn the diagram, And this F dot dr, according to our equation, we calculated, we named it as 1, and the particle moves from O to P, P to Q, Q to R, R to O. We named it as 2, and we evaluated and we solved it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.